Introduction to Tank Management System. A tank management system, TMS, is a sophisticated real-time application designed to efficiently manage various operations within a tank farm. These systems are critical for the storage and handling of large quantities of crude oil or other liquids, facilitating operations such as stock reconciliation, automatic and semi-automatic movement of products, and interface with multiple control systems for seamless operation. Overview and functionality. Objective. The primary objective of the TMS is to ensure accurate and efficient management of the tank farm, from receiving crude oil to dispatching finished products. The system supports planning, monitoring, and controlling the storage and movement of products within the tank farm. Core components. 1. SCADA servers. Supervisory control and data acquisition. Servers form the backbone of the TMS, handling data acquisition and control. 2. Workstations. Operator workstations provide interfaces for monitoring and managing tank farm operations. 3. Tank gauging system. This system collects and processes data regarding tank levels, temperatures, and pressures. Key functions. Tank status management. Monitors and reports the status of each tank, including levels, temperatures, and pressures. Inventory calculations. Performs calculations for inventory management, including volume, flow rate, and weight. Alarm management. Manages alarms for various operational parameters, ensuring prompt attention to any issues. Movement planning. Plans and validates product movements from source to destination, ensuring safe and efficient operations. Automatic path selection. Automatically selects the best path for product movement based on predefined criteria. Crude oil movement storage reporting provides detailed reports on crude oil movements and storage, aiding in inventory management and reconciliation. System architecture. The TMS architecture includes SCADA servers, TMS workstations, and interfaces with integrated control systems, ICS, motor-operated valves, MOVs, and metering skids. This integration ensures comprehensive management of the entire tank farm operation. Data management. The TMS manages both static configuration data and dynamic operational data. Static data includes information about tanks, equipment, and alarms, while dynamic data encompasses real-time measurements and manually entered values. The system uses this data to perform inventory calculations, status monitoring, and generate reports. Static data includes tank identifiers and descriptions, equipment tags and specifications, alarm parameters and thresholds. Dynamic data includes real-time sensor data, level, temperature, pressure, manually entered data, laboratory density measurements, data from other systems, MCC, MOVs, metering skids. CHAC operator and engineering interfaces. The TMS provides user-friendly interfaces for both operators and engineers. Operator interfaces include graphical displays for tank status, alarms, and movement planning. Engineering interfaces allow for secure software configuration and management, ensuring that only authorized personnel can make changes. Reporting and diagnostics. The TMS generates various reports to provide insights into tank farm operations, including inventory levels, equipment status, and movement summaries. Diagnostic tools within the TMS continuously audit the system, identifying and correcting any issues to maintain operational integrity. Conclusion. A well-implemented tank management system is crucial for the efficient operation of a tank farm. It ensures accurate monitoring, control, and reporting of all tank farm activities, enhancing safety, efficiency, and reliability in handling large quantities of crude oil or other liquids. When specifying a crude oil tank management system, several key design parameters need to be considered to ensure efficient and safe operation. Here are the distinct design parameters. 1. Tank specifications. Tank type, floating roof, fixed roof, cone roof, or dome roof. Dimensions. Diameter, height, and overall capacity, e.g. 1 million barrels. Material, steel grade and corrosion resistance. Safety features, overfill protection, emergency vents, and fire protection. NAP 2. Measurement and instrumentation, level measurement, radar, servo, or float gauges. Temperature measurement, resistance temperature detectors, RTDs, or thermocouples. Pressure measurement, pressure transmitters for vapor space. Water detection, water cut meters or interface detectors. 3. Automation and control. SCADA integration, supervisory control and data acquisition system for real-time monitoring. PLC RTU, programmable logic controllers or remote terminal units for control logic implementation. Communication protocols, Modbus, OPC, or proprietary protocols for data communication. NAV4 data management. Static data, configuration data including tank identifiers, equipment tags, and alarm thresholds. Dynamic data, real-time operational data such as levels, temperatures, and pressures. Inventory calculations, algorithms for volume, density, ullage, and pumpable volumes. Historical data logging of historical data for trend analysis and reporting. 5. Alarms and safety systems. Alarm management, high-low-level alarms, high-temperature alarms, pressure alarms, and unexpected level change alarms. Emergency shutdown, ESD, procedures and systems for safe shutdown in case of emergency. Leak detection systems, systems for early detection of leaks in tanks and associated piping. 6. Control and operation interface. Human-machine interface HMI, user-friendly interfaces for operators. Remote monitoring, capabilities for remote access and control. Manual overrides, provisions for manual control in case of system failure. 7. System redundancy and reliability, redundant servers for SCADA and data management to ensure high availability. Failover mechanisms, automatic switchover to backup systems in case of primary system failure. Diagnostics and health monitoring, continuous system health checks and diagnostics. 8. Environmental and regulatory compliance. Environmental conditions, design for temperature ranges, humidity, and other environmental factors. Regulatory standards, compliance with local and international standards, e.g. API, ISO, IEC. 9. Integration with other systems. Pipeline interface, integration with upstream and downstream pipeline control systems. Metering systems, integration with custody, transfer, and metering systems for accurate accounting. Enterprise systems, interface with MIS, Management Information Systems, and ERP, Enterprise Resource Planning Systems for comprehensive data management. Number 10. Maintenance and support. Accessibility, design for ease of access to instrumentation and control systems for maintenance. Spare parts, availability and management of spare parts. Vendor support, long-term support agreements and training for maintenance personnel. By considering these design parameters, a comprehensive and efficient crude oil tank management system can be specified, ensuring safe, reliable, and efficient operation. Tank Management System. TMS functionality. The TMS software shall provide comprehensive functionality to ensure the efficient management of the tank farm operations. The primary functionalities include scanning of field equipment values, continuous monitoring and scanning of field equipment values. Manage tank status, real-time status management of all tanks within the system. Manage tank basic data, management and reporting of basic tank data, including current statuses and movement details. Manage tank limit data, performing basic alarm functions based on tank limit data. Perform inventory calculations, calculations for inventory management, including volume, flow rate, and weight. Provide ullage and pumpable values, calculation and display of empty space, ullage, and pumpable values. Volume, flow rate, and weight calculations, comprehensive calculations for operational efficiency. Interface to control system, ICS, seamless integration with the ICS for operational control. Display of measured values, parameters, and alarms. Graphical and tabular display of all relevant data. Definition and/or configuration of tank database data. Setting up and configuring tank database information. Movement planning and control. Planning and control of product movements, including automatic path selection and swing operation, tank changeover. Equipment monitoring and management, real-time monitoring and management of all equipment. Crude oil storage management, comprehensive management of crude oil storage. Crude oil movement, storage reporting and archiving, detailed reporting and archiving of all movements and storage data. The system architecture of TMS includes the following components. SCADA servers, central servers for data acquisition and control. Operator workstations with user interfaces for managing tank farm operations. Interfaces with ICS, MCC, moves, and metering skids. Integration with various control and monitoring systems. Printers, for generating hard copies of reports and other documentation. TMS data. TMS handles both static and dynamic data to provide a comprehensive view of tank farm operations. Static data. Static data includes tanks, identifiers, descriptions, types, and capacity details. Equipment, tags and specifications for movies, pumps, and metering skids. Alarms, configuration and thresholds. Dynamic data. Dynamic data includes real-time measurements, data from level, temperature, pressure, and other sensors. Operator input data for various parameters. Data from other systems. Integration with MCC, MOVs, metering skids for comprehensive data collection. Calculated inventory and operational data. Operational data. Calculated data includes total volume, water volume, gross and net volume at 15 degrees Celsius, density at ambient temperature, safe volume, ullage, pumpable volume, product weight, time to limits, volume correction factors. Status data. Status data includes tank status, unexpected level changes, alarms, TMS system control and operation. The TMS software supports the management and operation of crude oil movements and storage. It includes functionalities for receiving and verifying quantities of crude oil, recording quantities of finished products shipped, and providing reconciliation and closure reports for the tank farm. The TMS communicates directly with the Management Information System, MIS, for forward planning of tank farm and SPM operations. It also interfaces with the automatic tank gauging system to monitor tank levels, temperatures, and pressures. Operator interface. The TMS provides a user-friendly interface for operators, including standard tank graphics and information presented graphically. Key displays and overlays include time to limits display, tank variable data display, tank fixed data display, tank quality overlay, select tanks overlay, alarm summary, movement planning, current alarms display, alarm history, engineering interface. The engineering interface includes functionalities for system definition, equipment definition, data entry, movement calculations, and plant topology. The interface is protected with different access levels and password security to prevent unauthorized modifications. Reports. Reports generated by the TMS cover all operations and equipment status. Key reports include actual report, snapshot data, individual tank report, actual data per tank, historical level report, hourly levels, out-turn report, equipment status, movement summary report, individual movement report, exception report, daily movement report, pumping equipment utilization, custom reports configurable by the operator without requiring special programming skills. Diagnostics. The TMS includes an audit program that automatically audits all aspects of the software, taking corrective action when required. The audit program is designed to locate errors caused by program termination or hardware failures. Audits run continuously or at predetermined times with non-fixable errors alarmed to the operator. A diagnostic display provides the status of all elements, commands, messages, and alarms associated with tasks or movements. Tank Management System TMS specifications. TMS vendor's responsibility. The vendor is responsible for the following: applying professional engineering methodology to the design, testing, and documentation of the TMS software, collaborating with the purchaser for TMS configuration, supplying the latest release of all applicable software at the time of bid presentation, ensuring no obsolete or superseded releases are offered, developing interfaces between different systems, e.g. MCC, MOVs, metering skids, and the TMS software. Requesting additional information at the tender stage to ensure complete and successful integration with third-party systems, ensuring compliance with project specifications, codes, and standards, even with purchaser-approved software and drawings, providing complete software and services suitable for the intended duty. TMS system vendor's experience. The vendor must have a proven track record over the previous 10 years in providing design, engineering, supply, and commissioning services for large-scale, multinational, continuous process projects in the oil and gas, petroleum, refinery, and petrochemical sectors. Provide references for successfully completed projects involving TMS software similar to that proposed, particularly in the same geographical location. Include in the reference list details such as technical order size, year, hardware, and software revision levels. 6. Project management. 6.1 Project personnel. The vendor must ensure sufficient qualified personnel are allocated to the project at all times. The use of a project team structure to achieve continuity and quality of project implementation. The provision of an organization structure for the project team, engineering and project management, along with curriculum vitae of key personnel. Inclusion of independent qualified personnel for key functions like interface development with ICS, software testing and debugging, FAT procedures, system integrity tests, and safety procedures. The project manager functions as the single point of interface for any project issues. 6.2 Project schedule. The vendor must produce a detailed project schedule showing major schedule milestones. A project schedule used as the basis for progress reporting, schedule controlling, and schedule forecasting, revised regularly to reflect actual project progress. 6.3 Progress reporting. The vendor must submit fortnightly progress reports covering engineering progress and manpower involved against the project schedule, highlighting any delays. Proposed specification changes. Software and programming status. Immediate reporting of any encountered or foreseen problems. 6.4 Coordination meetings. The vendor must schedule an initial kickoff meeting to review the total project scope and verify project schedules. Conduct regular coordination meetings on a monthly basis at the purchaser's premises, attended by key members of the vendor's project team. Prepare detailed meeting minutes and an action item log, continuously updated by the vendor. 6.5 Systems engineering. 6.5.1 Consultation service. Provision of a lead system applications engineer responsible for providing technical guidance during project execution, assisting in finalizing control and operating strategies, and addressing any questions regarding performance specifications and installation. 6.52 Programming services. Provision of programming services executed at the vendor's or purchaser's premises. Generation of a final approved program free from software patches, delivered on a fully tested and verified system configuration CD-ROM. 7. Quality assurance, inspection, and testing. 7.1 Quality assurance. The vendor must operate a quality system in accordance with an internationally recognized standard. Submit a quality control program for purchaser review at the time of the tender. Provide facilities for and cooperate with purchaser and inspectors during manufacturing, assembly, and testing. 7.2 Inspection. The vendor must permit the purchaser or its authorized representatives free access to all parts of the vendor's workshops concerning the development and testing of the TMS software. Comply with the purchaser's third-party inspection and certification requirements. 7.3 Testing. The vendor must carry out all testing at the vendor's test facilities prior to delivery for system integration testing. Supply an inspection test plan ITP with the tender. Provide the purchaser with at least 14-day advance notice to witness tests performed in either the vendor's shop or sub-vendor's shops. Conduct testing at various stages as the TMS software is developed, including development testing, pre-factory acceptance test, pre-FAT, factory acceptance test, system integration test, site loop tests, site acceptance test, SAT, and availability test. 7.4 Test procedure and recording of results. The vendor must carry out all tests according to a test procedure specification prepared by the vendor and agreed by the purchaser. Maintain detailed test records for all inspection and testing in the agreed format. 7.5 Test documentation. The vendor must maintain detailed test records for all inspection and testing carried out by themselves or subcontracted third parties in the agreed format. 7.6 Test failures. The vendor is responsible for all costs associated with rectifying and retesting any defects discovered during the inspection and testing procedures. Retesting any affected software if faults are discovered during testing. 7.7 Punch list clearance. The vendor must include adequate time within the testing schedule to enable system rework and retesting of punch-listed items observed to fail during testing. Clear outstanding punch list items before the software is shipped to the site or at the commencement of this AT stage. 7.8. User software verification and testing. The vendor must have a verifier examine the code for compliance with functional specifications, completeness, and quality of documentation. Ensure discrepancies are reviewed and resolved by the testing team, programmers, verifiers, and test procedure writers. Implement agreed code corrections and retest the corrected code against the test procedures. 7.9. Discrepancy resolution. The vendor must report any discrepancies between written test procedures and observed results in detail. Resolve discrepancies by consulting with the testing team, programmers, verifiers, and test procedure writers, with potential ambiguities referred to the purchaser for resolution. 17. Change control. The vendor must implement change control to ensure all software changes are recorded for review and approval before being made. Changes will be classified as either major or minor. 7.11. Pre-FAT TMS system vendor in-house testing. The vendor must complete pre-FAT to provide in-house validation testing and quality checks to ensure the system complies with the TMS functional specifications before the FAT. 7.12. Factory acceptance test. The vendor must ensure the FAT confirms that all deliverable items are present and acceptable, and the TMS system functions correctly according to the functional specification. Submit proposed FAT procedures to the purchaser 3 months before the scheduled FAT date. Allow the purchaser to witness the entire FAT and provide a signed copy of the FAT procedures and related printouts to the purchaser. 7.13. Systems integration testing. 7.13.1. Overall TMS system tests. Conduct the system integration tests on the entire TMS, ICS, RTU SCADA system, and other devices with all interconnections equivalent to the final installed configuration. 7.113.2. Operability testing. System response times. Test system response times to common operational requests from the ICS operator station under simulated system conditions and log response times for comparison with the functional specification. 7.13.3. Alarm flooding tests. Test the alarm handling performance of the TMS software under simulated system conditions and log the response to ensure reliable capture of alarm and status information. 7.14. Installation and site acceptance tests. 7.4.1. Installation tests. Develop a delivery and installation plan in collaboration with the purchaser and inspect the TMS software for anomalies or failures during the 48-hour period following installation. 7.2. Site acceptance tests. Base the SAE on a subset of the FAT procedures supplemented by site-specific tests. Maintain detailed test records for all inspection and testing carried out at the site. Ensure the SAT confirms the TMS software has been correctly installed and operates reliably to specification in its final environment. 7.14.2.1. Objectives. Ensure all deliverable items are present and acceptable. Verify the correct functioning of the TMS software according to the functional specifications. Ensure the system can tolerate failure of individual modules and subsystems and recover to full function following repair. Confirm that all remedial punch list work from the FAT has been satisfactorily completed. 7.14.2.2. Software testing. Retest a random sample of ATG devices to verify TMS-ICS interfacing. Conduct an availability test for a continuous 60-day period to ensure the software meets availability requirements. 7.15. Software initialization, commissioning, and startup. The vendor must identify any special requirements for vendor support during commissioning and startup. Make experienced startup engineers available to assist with installation and commissioning of the TMS software. 7.16. Site support. The vendor must describe the local support available, including maintenance personnel, workshop facilities, mobilization time for personnel and spares, availability of 24-hour support, and remote dial-in maintenance support. Offer field service agreements with factory-trained specialists available on a 24-hour basis. The vendor must provide detailed training programs for maintenance technicians, plant operators, and system engineers. Include training at the factory and site training for the owner, addressing overall TMS software capacities, programming functionalities, maintenance functionalities, validation procedures, decommissioning procedures, and other relevant guidelines. Offer operational and maintenance training on the ordered system at the principal's location. Conduct training in English.